Good afternoon, everybody. Uh, Good to have you back. Hope you've enjoyed a nice luncheon. We're now reaching the second part of our event today. We're now about to kick off the Sylvanus workshop and platform showcase. This session will be divided into several phases, each providing valuable insights into the development and impact of the Sylvanus platform. We have an excellent lineup of speakers, including experts from various fields who will give us a deeper understanding of the platform's capabilities and its potential applications for wildfire management. Our chair for this session is Professor Ibro Izquierdo from VTG, who will guide us through the presentations and discussions. So let's now dive into the program. Professor Ibro, the floor is yours.
Working? Yes. Okay. Thank you. Thank you, Douglas. So the way we have structured this section today is a sort of workshop. We want to start with the technical part. As I mentioned last Monday, the Sylvanus platform is driven by this structure which is here, the three phases starting from prevention, moving into response, and then into restoration. So these three phases have been driving all the developments of the platform. And the way we have structured the technical presentations today are also aligned this outline here, starting with phase A, which will come next, and then phase B, technical level, all of this technical in the context of the platform, and then concluding with phase C. After we have these technical presentations, we would like to ask you to save your questions for the end, because what we want to do is once we have these three technical presentations, which will be roughly 90 minutes in total, so half an hour, half an hour, half an hour, then we want to have a long workshop, which will be interactive in the sense that we will have here our master dashboard, which is in the back there, Marcin, driving you, showing you in real time a demo of the system. So the dashboard, not the system, because the backend is huge. That's somewhere in the servers and in the cloud. So he will have here the dashboard, and then one of our users, I believe Marek, will be also here guiding you through how the user will be interacting with the platform, with the dashboard. So yeah, thank you. So we start then with phase A. You have something to say?
Do you want me to?
Yeah.
Need to turn on the mic there. We begin with phase A of the workshop, and we're pleased to announce Konstantinos Demestichas. Sorry if I'm not, from the Agricultural University of Athens. In this phase, Konstantinos will take us through key aspects of the Sylvanus platform, discussing its design, development, and the technologies that power it. Please give him a warm welcome, please.
Thank you, Douglas. Thank you. So, thank you very much. Just a minute to... First of all, many thanks to Rogerio and his entire team for hosting and the excellent organization. We really appreciate it. To Douglas for moderating not only today, but also yesterday and the day before, and the amazing speakers that you have selected and who had the honor to listen to. And we appreciate a lot, even more, that Brazil has a central role, and any deforestation here impacts the entire planet. So thank you very much for this. Now let's dive into the first presentation from Sylvanus. Okay, the translations are machine translation, so there will probably be a lot of mistakes. Just to have a sort of visual guidance, and I guess it helps a bit to make the presentation a bit more accessible, but certainly there will be some errors. In any case, as Ebrul mentioned, the Silvanus platform is a huge platform that hosts almost 25 different tools. These different tools and functionalities, we group them together across the three phases, so prevention and preparedness, suppression, and also phase C, restoration. Of course, one functionality on one tool can also be used across different phases. So this is not, let's say, a very strict categorization. And you see here only part of the picture, but with the different colors. So the light yellow, green are mainly phase A, tools and functionalities. Phase B are the red ones, and phase C, but there are more. So this is not the complete picture because it is quite huge, are for phase C. So we try to have this integrated approach where from a single entry point, from a single dashboard, a user, be it a firefighter or it could be also a different type of user, a forester, a researcher, a policymaker, and so on, can also access the different tools and functionalities that he or she needs. So in this first presentation, we will focus on phase A, and then we will dive into phase B and C in the next presentation. So talking about phase A, the first thing that comes to mind is training. So training for firefighters, and this, and during the Silvanus project, what we did was to develop an AR and VR platform that can be used for training of firefighters under different scenarios, under different challenges on the field. And the good thing is that one can not just be the player, but also you can customize the scenario that you use for training. So before going into an actual field training, you can also use this sort of VR training. So I will check if, okay, it's a short video just to have an idea. So the idea is that you can use a scenario in order to train your firefighters, and of course you can assume the role of a firefighter in order to to use the different types of equipment and so on and so forth. In phase A, so prevention and preparedness, fire danger plays a key role. So there is a specific tool and a whole pipeline of functionalities where we use machine learning models taking as input meteorological data, the land use, the vegetation state in order to compute on a daily basis this fire danger index, the FDI. So what the user sees is this sort of diagrams where the scale is from 1 to 5 to 6. And then this is computed, as you see, on a daily basis, so it can change from day to day depending on the conditions and the meteorological data. Another key tool in phase A is the detection of smoke or fire, the ignition at the field, inside the forest, using sensors and what we call IoT, the Internet of Things. So during the project, we started with utilizing open hardware and sensors in order to create this sort of sensor arrays and toolkits that can be used inside the forest for early detection of fires. These are equipped with environmental sensors, so temperature, humidity, GPS sensors, and also they have a camera that can be used to recognize smoke or fire. One of the challenges was that first of all, we had to select and test computer vision algorithms that can be executed on such a small computing platform, which has been a challenge. And of course, another challenge was that the battery consumption that needs to be quite low, and we are still working on it and on different solutions. It has a rugged case and can be mounted, as you can see, on poles, on trees, and so on. So it is a cost-efficient way to detect fire at the edge inside forests. What you see here is just a glimpse of the entire dashboard that you will see later in more detail, but you can see that you can activate so whatever tool you need right now. So this is the smoke and fire detection based on sensors that I have explained. And you can see the results on the map, and when you click, you can also see details on the sensor outputs at the right hand side. So different tools across the phases, all in one place, and they are relatively easy to use and to activate and deactivate. So this is what you see at the front end. Another important tool and functionality is the detection of fire using what we call social sensing, which essentially is a scanning through social media channels for specific keywords that have to do with forest fire events. And then what we do is we automatically extract through natural language processing, through NLP, the key entities like timestamps, places, the severity of the fire, and we can use this as another source, a crowdsourcing, let's say, a type of information that we can display to the decision makers, and they can decide if we need to act or not. So not only electronic sensors, but also human sensors can be utilized and can take part, and this is a type of engagement inside the SILVANUS platform. And again, the same dashboard, but you activate a different, and you can also activate multiple layers, of course, but there will be a more complete demonstration later on. If there is an event through social sensing, you can see the details, the posts on the right-hand side, and the key information, so the location, the time, and so on, are automatically extracted. Another type of fire detection at the end, so just before a fire starts, is using unmanned ground vehicles, UGVs. So during the project, one of the partners has developed this, they had them already, but it was a chance to test them more extensively. And they have trucks, not wheels, that they can use to navigate throughout the forest region. They are also equipped with cameras and LiDAR sensors, meaning they can calculate distances and have, let's say, very sophisticated situational awareness. You can see also a lot of some of the people that were present in the Australian demo and had the chance to see them in action. So a lot of the challenges here come from the engineering part, so making a reliable UGV that can navigate through complex terrain, and it can find also its way, it can avoid obstacles, and so on and so forth. And you see here on the upper part what the UGV sees with its LiDAR sensor, and can this is the scene reconstruction using the LiDAR and also the camera sensors that it is equipped with. Another important application in phase A, it's what we call Hoodie, but you have seen, I think it was playing in a loop during the break. So it is a mobile application that can be used for biodiversity profiling in a region at a global scale. You can use the app to take photos, and these are scans that can be uploaded to an image recognition software that can find what type of species it is, if it is, of course, registered in the database, and show you some information. So it is good as a biodiversity profiler, so to say, but there are also new exciting functionalities that you have seen inside the videos, and they have been added. Using Gen AI, you can see a landscape or a specific tree, how it would look if it was damaged or burned, and how it can be restored. So it also has a more, let's say, educational and engagement functionality that can be used. This is another mobile application developed in the SILVANUS project. So this has an educational character and engagement, and you can use it to learn about wildfires, to learn about the causes, the effects, what you can do to prevent wildfires, what you have to do if you see one happening. So all these things that as citizens we have to know, they are all this important information is curated, put in one place. And of course, here in Brazil, it can also be used, but perhaps we need also your help to customize it a bit further to see if some new information, important information, can be added. Other than that, it's very usable, and you can install it on your mobile phone. I will leave it here for just a moment if you wish to scan it and install it. Then we have another tool and functionality. I will go more deeply on this. It was not possible to go in very fine detail for all the tools because, as you have seen, there are many. So one of these tools, I will go through it more completely. In more detail. It is called Earth Observation. It's the EO for wildfires. What it does, what is the problem behind it, and the objective is, let's say that a fire starts. We don't know if it starts, but let's assume that it starts somewhere. It ignites. Can we have an estimation of its impact? So this is the purpose of the tool, to help us estimate, predict the size of the burned area. It does not predict whether a fire will ignite. Okay, there are other tools, other algorithms from a statistical point of view that can help you do that. But assuming that a fire will start at a specific area, then we can try to estimate based on data that I will explain later, the size and to some extent the shape of the burned area. So this is an impact severity, let's say, estimation, but it is beforehand. So how we imagine that this tool can be used as a preparedness measure. So you use data for the day, the next day, and then you can predict whether there will be a large impact of a forest fire, and then you can decide if you want to be prepared for that and deploy more forces, and so on and so forth. This is the focus of the model to try to predict the severity of wildfires, and we use different types of data from a system that we call EFIS. In Europe, it's the European Forest Fire Information System, data that come from meteorological data and also satellite imagery. We have created an open data set that you can also use as a researcher or as authorities. You can use it. It's available for free online, and it's a public open data set. And Hugging Face is also a repository that is very convenient because you can see also instructions that you can use. So a few commands that you can type, and you can use this data set in order to develop a machine learning model of your own. So your notebook starts, and it's ready, let's say, to be used with a machine learning model that, of course, you can then, perhaps you have an idea, you can fine-tune it, you can improve it, and deploy it later on for your area. These are the types of data that we use for this tool. F is that, as I explained, it records information about fire events across Europe, so locations, intensity of fire, land uses, and so on. Two types of satellite data from Sentinel-1 satellites that has SAR data that we can use, synthetic aperture radar, and Sentinel-2 data, which is a multispectral type of satellite that passes by and has 13 different spectral bands that you can use for remote sensing. For meteorological data, we scan through NASA power in order to get different types of meteorological data that we can use for training machine learning models. So these different types of data sources, as I said, the first one is the meteorological data, so different parameters involving temperature, humidity, soil humidity, and so on. The SAR data, and in the third column, different bands, different spectral bands that we can use. Now, EFIS has a collection of fire events. Okay, historically, it records all the fire events in Europe. So for each of these fire events, which are a lot, we go and collect the corresponding data for that day and 30 days before. So 1 month of data for each fire event, meaning meteorological data for that day and the previous 30 days, Sentinel-1 and Sentinel-2 data. So all these different types of data are correlated and to specific fire events. What we end up with is what we call data cubes, and we use a very common format for GIS systems called NetCDF. And we have over 31,000 fire events that we can use, but they are correlated to meteorological data, as I said, and to satellite imagery for that specific day and for 30 days before that. And then you have this data. It looks like this. So these are different fire events for 5 years from 2018 up to 2022. We plan to update this data set with other years as well, but it is not so easy, so it will take some time. The yellow polygons that you see are the administrative boundaries, the level 4 administrative boundaries for affected areas, affected forest areas by the fire, and the red points are locations of fire events. So you see the different fire events for these 5 years in Europe and also in some regions in the Mediterranean also. The frequency of fire events, so there are countries that have more frequently fire events like Turkey, Greece, Italy, and so on and so forth, but this is not the impact, but only the number of fire events, regardless if they are very impactful or not. What we did after we created this, assembled this open data set, what we did was to create a series of experiments, so to try to develop deep learning models that can predict the burned area size. First using all the data, then removing from the training set those data that, those let's say fire events that were minimal, that were not so impactful. And we split this data set, so approximately 20,000 training event, approximately 5,000 validation, and the evaluation was over 6,000 different FAR events. We utilized different models, so belonging into two large categories. I will not go too deeply on this. So image segmentation networks, a type of deep learning model, and another one, visual transformers. And we compared their performance, which actually was quite, let's say, similar. So not so large differences. This is the pipeline that we had used in order to be able to perform the training, and for anyone interested, there is more information inside our relevant publication. I have selected just a few case studies, examples that you can see in order to understand better what it does. Unfortunately, we did not have the possibility to use examples from Brazil, because we did not have data, satellite data, but also data about fire events in Brazil. But perhaps with your help, we can enrich this data set to make it at a more global scale. In Europe, it was a bit easier because we have EFIS, so it was, let's say, relatively easier to have this open data set. So you can see here example from France. So this was an actual fire that was, this is the red area that was burned, and with the green you can see the prediction. So it's a prediction, so we don't know what happened. Okay, so we don't see the burned area. We predicted beforehand, before the fire occurs. You can see here also another example. We underestimate a bit the burned area size, but you can see that the algorithms also tries to approximate the shape of the fire. And another also example. So the ground truth is the red color, and the green color is the prediction. And some more examples from Greece. Here we have from the region of Evia. You see here that there are the approximation is better in these specific examples, so we can estimate not just of course, this is an approximation, not just the size, but also the shape that you see here. And here also other examples where the prediction is the blue, the cyan color, and the ground truth again is the red color. And you can see here the inputs that we have used. So the inputs are the 30 days before a hypothetical event. These are some more examples from Evros. So in Evia we had a very devastating event in Greece, where the northern part had a very large forest that was burned, more than 50,000 hectares. In Evros, back at 2020, okay, there was a fire. It was not so devastating, but then another fire came that burned more than 90,000 hectares, so it was even more devastating. You can see here the prediction, which is the darker gray, with the ground truth, which is the light gray. And here some more examples from another community, another village, let's say, in Evros, and also in Evia, that were burned, where we try to approximate the impact of the wildfire. So what we realized from this last tool is that we can use deep learning models to predict the impact of a hypothetical wildfire before it happens, so that we are more prepared to deploy resources and forces on the ground. So this means that as long as for the next day, let's say, we have some reliable meteorological data, or for the next, let's say, 5 days, then we can use this sort of models to as a decision support tool. Of course, we realize that open data are, and especially correlating data from satellites to actual fire events is very important. So we are also in support of publicly available open data. For the future, we see that we can, of course, improve even more. You see that in some cases there is an underestimation, but the order of magnitude is the same of the expected impact compared to the ground truth. And also, what is important is that we can also use the same approach in other places of the world, as long as we are able to collect data, and we could use a type of transfer learning to train models for other regions like Brazil as well. So this was an overview of the entire phase A, and also a more of a deep dive to this specific tool. Thank you very much. AUA, Agricultural University of Athens. Γεωπονικό Πανεπιστήμιο Αθηνών.
Was that clear?
It's a challenge. Γεωπονικό Πανεπιστήμιο Αθηνών. Thank you. Yeah. Γεωπονικό is agriculture, Πανεπιστήμιο is university, Αθηνών is Athens. Okay. Thank you so much. Thank you.
Thank you. That was great. Thank you, Konstantinos, for that comprehensive overview of the platform's design and its functionalities. It's great. Oh, okay. It's great to see how these tools are being developed to support wildfire management and prevention efforts. Now, we move on to phase B, of course. For this session, we're excited to have a team from net company Introsoft, including Despina Anastasopoulos. You wanna say the names? All right.
It's gonna be me, Despina Anastasopoulos, and my colleagues that will also take this floor in order to present a bit the technical aspects. I don't know if you want to say it.
Please welcome them to the stage.
Okay. Thank you.
Thank you.
Okay, as an idea, just for today, we thought that we should put a little bit of a context of who we are before we start the technical descriptions of our work. And in just a sec, yeah, okay. Great, thanks. Yeah, that's okay. Yes. Oh, where's the pointer? Right. Okay, we come from Netcompany Introsoft. Just a few things about us. I think I totally described. I don't know. Yeah. Okay. We're a multinational company based in Denmark and also in Luxembourg. So we are here today as one of the main software integrators of SILVANUS platform. And just a few things for us. We are one of the fastest growing company in Europe, and our main actually asset and for this project was that we have a huge expertise in developing EU sophisticated systems, especially that are matched to the EU institutions. One of our key assets that we're developing currently is the EU digital identity, EU wallet. People might have known about it. I'm not going to spend much time because our colleagues from the project already know who we are, but I'm going to pass the floor to my colleague, Nelly Leligu, who's our professor, and also my other colleague, Fine Stefanoudakis, that will be bringing in the technical details regarding Phase B. And in this project, our typical role, let's say, apart from the overall participation that we had, was to provide our expertise in being the main technical integrator of the platform. And also we have developed a DSS that will be thoroughly presented by Fannis. Nelly, you want to take the floor? Thank you.
Thank you, Despina. Thank you, Rogerio. Thank you, Douglas. Thank you all for being here. It's really important for us to be able to share what we have done and collect some feedback from you. So, we are talking now about Phase B. Kostas earlier talked about Phase A. Phase B is about you have an event and you have to respond. It's the most difficult phase, to my mind, due to the criticality of the time. Okay. Thank you. So, for Phase B, SILVANUS has developed a quite rich set of tools and functionalities. I will restrict myself to a selection so that we remain as comprehensive and as to the point as possible. So the first tool that we will go through is the integrated data insights, the fire spread forecast, the decision support tool, which includes a set of other tools. And finally, in SILVANUS, we have also worked on infrastructure, let's say, topics to make sure that in the fire we do have some way of communication. So, I'm starting with the integrated data insights. As you have already seen in the previous presentation, we assume that there could be IoT sensors in the field, in the forest. There could be cameras, there could be UGVs. We could have people in the forest. So in the platform, a lot of different types of information is collected. What we do is that we homogenize them, we represent them in a specific format, in RDF triplets, and we semantically annotate them so that we can use it to answer questions of the responders. The responders are, by responders, I specifically refer to the firefighters and the civil authorities. So, questions that could be asked by the responders, and also alerts are the target of this tool. Alerts based on user-defined rules. What does user-defined rules mean? It means that we cooperate with the civil authorities, and they say that we would like to know when a certain amount of days there is no rain and the temperature is above this threshold, we want to get an alert. Okay, this is what it does. So we do have an alert generation framework. It distinguishes 6 different levels of severity. Okay, you are very familiar with severity levels and criticalities. So examples of alert that SILVANUS platform can support are, dry conditions. It is something that I heard a lot today. When it gets dry and I need to know the hotspots. Why do you need to know the hotspots? I have understood, but it's your role. We take care of saying to you where are the hotspots. Fire detection, it's a very, very important thing. Smoke detection, combined conditions, air quality, and many, many more. Let's pass to the next tool, which is the fire spread model. Kostas talked about a tool that can predict the spread of the fire if it happens in 30 days. Okay, the fire spread model is the following. Through different channels, you may receive, the first responders may receive an indication that there is somewhere a fire event. I don't think that you rely on what the technical tools say. I think that you go there and check. So Once you go there and check and you confirm that there is a fire event, we assume that the commander would be able to draw, to draw the current fire front. So you go there, you see the fire, you see how much it has spread, and you draw the fire front in the SILVANUS platform. Once you draw the fire front, based on hourly weather forecasts, we use artificial intelligence and deep learning technical things here to produce what? To provide an estimate of the fire front location at different times in the future, meaning now, in 15 minutes, in 30 minutes, in 60 minutes, etc. And we do this for a maximum of 24 hours and a forecast area of 3 times 3 kilometers, and with a granularity, high granularity to my view, 10 by 10 meters. Our challenge was to achieve high accuracy and to do the calculations very, very fast. This, again, is based on real-time information. So the novelties here is that we feel that the tool is intuitive to use. We have a very good speed of processing, so that in 5 seconds you have the spread forecast, and finally you have a probabilistic outcome. How you see it? Okay, you already know that this is the SILVANUS platform, and here is the menu with the different tools. If you go to the fire spread simulation, you can select 0, 15 minutes, 30, 60, etc., etc., and you do have different things on your screen. Here is now the fire. It can be like this in 30 minutes, in 60, in 3 hours. You see the time here. You also see it in the menu, and in 6 hours from now. Of course, if it evolves in a different way, you can draw another front line and press the button again so that it recalculates what will be done. Next tool is the decision support system. We talked a lot about decision support, and I will pass the floor to Fanny to let you know about this more.
Okay, so we have heard in all presentations today that we go from data collection to from raw data to information to knowledge, from our knowledge-based system to actionable insights, and we are moving to the domain of taking complex decisions by using our tools. One of these complex decisions has to do with the resource allocation in the field of the response teams. So when we are talking about complex decisions, we need to develop algorithmic solutions to complex problems that humans need to solve. So assume that we receive a notification that the fire spreads out in the Tijuca forest somewhere above the waterfalls. What do we do, and who acts in this situation? I guess some people inside the room might have taken some decisions like that in order to respond. What is the decision? Which is the nearest of amount of vehicles that I have that I can send to the incident? Okay, that's the obvious thing to do. And information that I have with respect to this, the distance from the location, how fast it can go there, I do some calculations, I do the math, and I send out the command. Okay, but as you have seen, we have now our crystal ball that tells to us where the fire front will be spread in 1 hour, 2 hours, in 4 hours. So we know that as time passes by, the situation will get as closely as to this that we can predict, assuming that this might be very accurate. Beyond that, we know that in these places, people live. They are spread somewhere in some of those locations. Some of those locations are of high critical value because factories might be there, nuclear stations, whatever, that might have very high impact of being hit by the fire. And we have our resources, and we know that we have several of those, but they are available within the next half an hour, but more of them might come in the next 2 hours, in 4 hours, etc. Can we combine and solve this problem and make the math in this case? No, this is a hard thing to do. So this is where, again, information communication systems might help us to minimize and solve these kind of problems that always are trade-offs between of what we have and what we can do, but taking into account that the fire spread projections that we have in place, the distribution of our population in our map, the resources that we have available and their characteristics, their capacity, their suppression rate, possibly a cost to use them, and the intensity of the fire, how many resources do we need in order to put it out, and potentially a total budget that might take the form not only of cost in terms of money, but it might be, I have 4 airplanes, but can I send them all together at the same time? It might be an issue of risk and contingency plans. No, I might not want to do that. So do the minimization and try to solve this complex problem of protecting the population, protect the forest at the same time, and keep your overall budget, keeping in mind that you have limited resources, that you cannot solve the problem at once. So this is how it looks in the dashboard as we were showing. This, we have on the left the fire projection produced by our FSM model. On the right hand, we see our population distribution. So this is a different heat map. And we try to overlay one over the other so as to take the decision on where to put our resources. But our resources, as we mentioned, they are varying, their availability varies according to time. So different amounts of them will be available in different time scales. So we feed all this into the machine and we try to come up with a solution. And what kind of a solution do we get? This is how it looks on the SILVANUS dashboard. By activating this, the tool on the left, you can select the time scale again, and you can overlay the suggestions of the tool in terms of where to put your resources. We can see it later on as well. There, the rectangles represent values of resources and recommendations on where to put your resources in order to better protect your population and your assets, let's say, and where to put the available resources at each point in time, within the next half an hour, within the next 2 hours, within the next 4 hours, etc., calculating how the event, the fire evolves over time. And a second assisting tool to this is a simulation tool based on the same algorithm, where we can play with the scenarios and do the same exercise again and again, and even simulate different scenarios of fire spread. You can change the conditions, you can try to solve different situations, and you can also compare the human solution to the automatic solution provided by the machine. This is again a usable tool because you can run it as many times as you want, and you can see what you have in an hour, where you select to put your resources. The marks there is a solution. In the next evolving hours, and you come up with a total overall cost. What is burned, what is saved. So this is the obvious outcome. So this is obviously an assisting tool for a complex situation, improving situational awareness, making informed decisions. Of course, it can be improved. We might, and the accuracy of data is always important. And we must take into account that there's no optimal solution that you can save everything. So it's always a problem of making trade-offs. Then moving into other domains of assisting commanders during firefighting. We are in phase B, you remember. Other tools provided by SILVANUS during the fire incidents on how to respond into cases where you need to take into account the protection of your citizens or your firefighters based on the conditions in the field. So again, we utilize data coming from our sensors in the field. Obviously, during fires, we have poisonous gases and conditions that may be harmful for people, and we need to respond accordingly in order to protect and, most important, take decisions about evacuation. So, again, in order to feel this and understand the situation, you need data coming from monitoring points. So you need to measure these emissions, characterize the area, the air quality, assess the impact on health, and respond accordingly. This is our hardware layer, our sensor layer, on how to sniff the air actually in order to measure and detect all these harmful gases and particles. So we need gas sensors and particle sensors. Of course, we need the electronics that gather, measure, and transmit this information to our centralized system. Remember that SILVANUS is a technological platform, so this is the platform and this is how data flow inside the system and are received over the cloud to a central platform. And this is how we can distribute our sensors in the field. You can put it statically in a box, you can mount it on an autonomous vehicle, and you can spread as many of them as you can outside in the field. We assume that you have this capability. If you have the data, you have the understanding, the situational awareness. Then health studies tell us about the criticality of this and the impact that this might have to human health. We can develop indices based on these studies and the expected impact on human health about how harmful these exposures can be over a time period. And based on this, again, we can do the math, not us, but the computer can do the math and tell us a combined index of how bad the situation is. Taking this information into account, how bad the situation is, we can make decisions on prohibited areas and evacuation decisions that we might need to take and areas to avoid. This is how the information appears on our SILVANUS dashboard about each point in each measurement point that we have, reporting this combined health impact index that we can calculate. Moving on, having this information in mind, again, as I mentioned, this has to do with taking decisions about evacuating and being protected from dangerous areas. So what the tool can do for us, in this case, the SILVANUS platform for us, this is also a tool developed by our partners in the project that has to do with the calculation of the evacuation paths. We know that we have Google Maps and we can navigate anywhere there is information about the availability of roads, the traffic, but now we have another layer in our case, which is the conditions in the field with respect to the safety of the route. So incorporating this data into the calculation of our routes, we have our evacuation planning tool and algorithm that helps us calculate the shortest evacuation route, ensuring safety, which is the additional point. Again, the architecture works the same way about collecting information from external sources. Here we need to gain information from external tools like OpenStreetMaps, Google Maps, etc., that help us calculate the routes. But we also have, we add our additional layer of safety, as we mentioned. And talking about safety, we overlay this information that has to do also with modeling of dispersion of the poisonous gases in the area based on our models, again, that we can project how conditions evolve over time and how these poisonous gases might spread and affect our areas based on measurements that we do in the field, and end up with some proposed evacuation paths in the area on our map that are characterized as safe or not, and help us again make the decisions in the next critical hours. Again, this is how this information ends up being presented on the SILVANUS dashboard about the information of its proposed plan. I conclude with some information about other people and other partners that have worked in this part of the project about providing tools and infrastructure, in this case, for phase B, for fighting the fires in the field. So when talking about response in the field in our technological platform, we talk about a distributed system, which is the SILVANUS by nature, that includes, well, the pointer is, okay, the cloud layer, the central part where information is collected. This is where AI takes place. This is where visualization takes place. SILVANUS is a software that runs in the cloud. But we also have the edge of our system, which resides, as I showed, in the field or near the field where the incidents take place, and includes the hardware that does the local processing, the local collection of the information from our sensors that are distributed in the fields. So we need gateway points to our central network, and we need also distributed edge processing systems that help us with the smart decisions in the edge. Because firefighters may be located at the central point, but also firefighters act in the field and carry such kind of equipment with them in order to help them respond locally. So we have the notion of the forward command center in SILVANUS, which is a kind of system that looks like that, deployed in one of our pilots. We see here, beyond the people that are working on the project, we also see the hardware deployed in the field. It could be used on a van, on a truck. It could be installed at a local station. But this is a computing point where sensor can be connected and act as our gateway to the system. And we can also add micro data centers that are powerful machines, and they can also provide local edge processing, doing the same, running the same algorithm, and most important, sharing the same information. These are interconnected to our central cloud platform. So everything you see on the dashboard at your central point, where you, the authorities, everybody is located. Also, the commander in the field can also share and see the same view and access the same information through the same infrastructure. And another thing we need to have in the field is to combat hard communication conditions, because mobile networks may fail. So we need also the hardware to help us overcome conditions where communication fails. And this, a neat way to do this is always to fly things in autonomous vehicles in the air. Drones, we know that they are fast, cheap, flexible, and they can do the job. And indeed, we have a partner doing exactly this in the project, providing an ad hoc communication network over the air, which can consist of at least 3 nodes that are communicate between among each other. And this provides communication to our forward command center, and from that point onward, we can connect with our centralized cloud platform. So this is how it looks in the field in our pilots in SILVANUS, where the Best in the Sky solution was deployed, loaded on a drone, carrying the equipment that provides this kind of software-defined radio solution in order to allow us to have a network connectivity similar to a Wi-Fi connection for a quite large range of connectivity, providing enough data rates so that firefighters can communicate, civilians can be notified and early on and have access to critical information without losing connection, whatever the conditions are. And I think this concludes my presentation of tools that help respond to phase B conditions. And we thank you as a team.
Thank you, Despina, Natalie, and Fanis for that insightful presentation. The user interface you've developed seems like a powerful tool for both monitoring and responding to wildfires. Next, moving on to phase C, we're excited to have Kusrni from Amicon with us. In this session, Kusrni will walk us through the integration of various data streams into the SILVANUS platform and how these are used to create actionable insights for fire management. This is a key aspect of ensuring the platform can support decision-making in real time. Kusrni, thank you for joining us today. Please, the floor is yours. Thank you.
Okay, hello everyone. I'm Kusrini from Universitas Amikom, Yogyakarta, Indonesia. Thank you very much for the opportunity given to me so that I can present one of the user product, SILVANUS user product, namely Open Forest Map. It's under phase C that will deal with restoration and adaptation. I will continue my presentation with Indonesian case of the phase C, and I will accompanied by my colleague, Gardias Bidari Adninda. I'll invite her to be here. Thank you. Yeah. Yes. As mentioned before, that SILVANUS have 3 stages of forest fire management, and we are in the last stage in the phase C that deal with restoration and adaptation. All of us understand that forest is important for our life, for our planets. And we already know that our forests have many burdens, including the forest fire. Okay. Then after the fire, there will be many programs, policy that will given to the certain area that experience the fire with a lot of resources, a lot of budgets, and that's why we have to know how the regulation, the programs will influence the level of the ecological resilience. What is ecological resilience? The speed of which disturbed ecosystem return to previous configuration and level of ecosystem functioning following the release of stress. Then we try to plot the climate condition like temperature, precipitation, and then community aspect, GDP, population density, and also forest condition, NDVI, NBR, together with the fire event and restoration programs, rehabilitation program policy, to know, to see how the rehabilitation and restoration program or the policy will influence the forest condition after the fire in the certain condition, in the climate community aspect situation. If we have many analysis area, then we can see which program is the best influence, the best effective, so that it can be the best practice to be based of decision making for our condition in the current and the future condition. But collecting the data time to time is very challenging because we need many extensive area in a very long time. So the challenge in the monitoring forest is how to collect data. There are 3 ways to collect data. The first one is on ground monitoring. Maybe we can send people to see how the forest is, but yes, this is like how many people that we have to send in the millions hectares we have. Then we also can use like sensors, but again, there is many limitation of that, and the on-ground monitoring, if we collect data start from now, then we will get the data from now on, from the now and the future. While the monitoring best practices, maybe we have to learn from many years ago. So on-ground monitoring, drone technology, maybe it will be alternative to collect the data, but we also need to get the data from the many years ago. One of that is using satellite. We know that like Copernicus, NASA, USGS, they already collect many years ago. So we can download the data and then analyze it. We can use the existing tools, but maybe it's also challenging because we have to download one by one in the certain area, time to time, and then we have to manage by ourselves so that we can learn from that data. Then one of the important variable in the satellite data is NDVI, Normalized Different Vegetation Index, that show the green level. The value is from -1 until 1, that it shows the dead plant or disease plant or moderately healthy plant or very healthy plant. Then we try to take the data manually, download the data from the sources, and then we take two places from two area from Cova de Beira that experienced fire in Augustus 1984 and 1995. We take the data and analyze the NDVI data before the fire, after the fire, and after the recovery. But we understand that one by one analysis is very, very challenging, and it needs the expert people to do that. So we try to simplify collecting data. There are 12 variable, fire event, soil type, program, policies that inputted by the administrator. Then we collect automatically Shannon index, evenness data from MODIS, and then we calculate NBR and DPI from satellite, and then we took precipitation temperature from era 5, we take GDP, population density for World Bank, all of them, then we visualize in the open forest map that have three main functions. The first function is ecological resilience index, and then continuous monitoring, and also biodiversity index calculation. And this is the open forest map. Let me introduce the application in a video.
Amicom is part of the SILVANUS project, which focuses on addressing the threat of wildfires and enhancing forest resilience to climate change. Forests are the lifeline of our planet, playing a crucial role in maintaining ecological balance. But every year, wildfires destroy millions of hectares, threatening biodiversity, human lives, and entire ecosystem. The challenge? Wildfires are unpredictable, and traditional monitoring methods are too slow. Accurate wildfire data is critical, yet processing satellite imagery is incredibly complex and time-consuming. Scientists, policymakers, and conservationists need a smarter way to track and manage wildfires. Introducing Open Forest Map. Open Forest Map is a wildfire monitoring tool designed to provide fast, accurate, and data-driven insights. By automatically processing satellite imagery and integrating key environmental variables, it simplifies complex wildfire analysis, empowering decision makers with the information they need. Open Forest Map gathers wildfire-related data from multiple sources, processes it using time series analysis, and delivers clear, actionable insights through intuitive data visualization. After logging in, users arrive at the analysis area page. Creating analysis area is simple. Input key details such as project name, area, and date. Select a region by drawing directly on the map. Choose a specific feature, including continuous monitoring index, ecological resilience index, biodiversity index, or multilingual alert system. When the analysis is complete, users can explore results through data visualization dashboard, displaying key insights such as NDVI, NBR, temperature and precipitation trends, GDP and population density, program regulation, and fire events. This streamlined process ensures that wildfire data is accessible, actionable, and reliable. By making wildfire monitoring faster, easier, and more accessible, Open Forest Map is helping us protect our forests and our future. Try it today by visiting our link below or scan the QR code to get started.
Okay, you can access the application in this link and try. Maybe you can give feedback to improve the quality of our application. Okay, and beside Open Forest Map, we also have other products and activities under phase C. One of them, we use data that inputted from WUDE that already mentioned by Kostas in the phase A. Then when the WUDE application capture the data, an image, then we will get what plan is that, when and where the data is captured. Then we will calculate it into the species biodiversity calculation index. Using a satellite, we have landscape biodiversity calculation index. Then using the Voodoo application and other sources, we can calculate the species biodiversity. We plot the data collected in the GIS, and we can also see the detail of the data. And then we try to cluster the data to see the level of the biodiversity based on the wide area and also the administrative area. So we can see which area is high diversity and which area is have low diversity. Okay, and another application user product, we have soil erosion index, is an advanced environmental monitoring system designed to assess and predict soil erosion in forested areas, particularly those impacted by wildfire. This tool integrated various data sources to provide the comprehensive insight into soil erosion dynamic, aiding the stakeholder how to manage and mitigate soil erosion effectively. The output is the result in CSV format, providing a comprehensive soil erosion index, then visualize the soil erosion risks and trend through numeric tables, graph, and detailed description report. And another one, we also continuous monitoring of Rehabilitation Strategies Index, or CMRSI, is designed to address the gap in evaluating post-fire recovery. We integrate both ecological and socio-economic factors into a single framework, allowing decision makers to monitor restoration progress in near real time. The index is organized using hierarchical into 5 levels. You can see in the right side. Okay, and then the pilots. In the phase C, there are 6 areas. It's Strelada in Greece, Tepilora Park in Italy, then Cova de Beira in Portugal, Gargano Park in Italy, Potpolani in Slovakia, and also Borneo in Indonesia. And I will introduce you to one of the national park in Indonesia, namely Sabangau National Park.
Sabangau National Park, pilot area of SILVANUS project. Indonesia, a country of a forest, the lung of the world. One of the preserved forests in Indonesia is Sabangau National Park, located in Borneo. Sabangau National Park covers a vast peat swamp forest around 542.141 hectares. During the rainy season, the black water level increased, and most of the area was drenched in water. Unfortunately, when the dry season comes, the water level decreases. The leaves and the peat soil get dry. That is when the forest fires mostly happen. The fire damaged this area in 2019. The fire ignition came from outside the area of National Sabangau Park and spread rapidly inside the forest. Now it remains the tree residue after 3 years. To recover the ecosystem, the stakeholders and partners conducted a rehabilitation process such as replanting vegetation. Sabangau Hulu and Kilometer 23 are examples of successfully recovered areas. SILVANUS project comprises 49 partners from the European Union, Brazil, Australia, and Indonesia, including Amicom University, and covers 11 pilot countries. We are working together to make an integrated technological and information platform for wildfire management. Better forest, better world.
Okay, and then the detailed case in the Indonesia perspective in the phase C will be explained by my colleagues Kardias Bidariak Ninda.
Okay, thank you very much for the opportunity. Hello, everyone. I would like to share a stories, a glimpse of Sabangau National Park. It is a case study from Indonesia, which cover a pilot from SILVANUS project. So here is the map of Indonesia. I believe that some of you already come to Indonesia, and also I would like to ask, or I would like to invite all of you, if you wanted to go to Indonesia, you can contact us, and probably we can go to the Sabangau National Park together. And here is the area of Sabangau National Park, which is located in the Borneo Island, or we call it Kalimantan Island. And you already seen it from probably from above, from the video, that we have a peat swamp forest in the Sabangau National Park. And it covers around 542 hectares of a peat soil forest. And in the Sabangau National Park, it consists of 3 administrative area, which is from Palangkaraya City, and then also Katingan and Pulau Pisau. And then after that, we know that there is a variation of a peat that depth between 1 meter to 12 meters, and in some particular area, it covers the depth of the peat up to 14 meters below the ground. And in case you are interested to follow some information from the Sabangau National Park, you can follow that link, but I'm afraid it will be on Indonesian language, so probably you can contact us if you need some information. Actually, this is a little bit history of Sabangau National Park, why we choose this area as a pilot area. The first is happening in 90s, that there are so many timber concession and also illegal logging in that area. That's why the company, most of them, built canals in all of the area of the Sabangau National Park to transport the timber going outside from the Sabangau National Park. And then after that, because of there are so many canals, and there is a degradation of the hydrological condition of the peat, there are so many repeated fires happened from starting from 90s up to 2000 and around 2022. And then after that, there are a little bit changes in the how to say, in the way the government take care of the forest. So after that, because of there is so many damage in the area, so the government make it into a Sabangau National Park. So the government make it into how to say, national park, which is a preservative park that is how to say, handled by the authority or handled by the government. So there is so many changes happen after that, after 2002. So because of that, there are so many restoration that is going on after that, going on by the Indonesian Peatland Restoration Agency, and it covers several activities. As you can see here, that there is groundwater level operation, and also the rainfall observation station, and also the most important things is the canal blocking to preserve the water that is previously lost in Sabangau National Park. And also we make a revegetation in several areas that is previously burned. And also we also have a natural succession in some parts. Yeah, here it's also almost the same. So the most important things that the government do to recover the hydrological condition is to rewetting through the canal blocking, because you know the most important thing in the peat island or in the peat forest is to maintain the water level, not to be very dry, because if it's dry, it will get burned easily. And once the peat soil is get burned, it cannot be back as peat soil again. So it will become some mineral soil. So it will be a different, different kind of, different kind of soil. So it will be, there is a changes in some areas after it burns. So that's why the government trying to make as many canal blocking as possible to hold the water. So it will be block the water going out from the pit area for around 25.46%. And it works. Here you can take a look at the condition in 2007. As you can see that there are not so many plant here, there are not so many vegetation in this area, but and then at the same time the government trying to build the canal blocking here, and then after that in 2010 we can see that there is some vegetations and it's growing faster up to 2013. Here is also the same as before. It is still talking about the revegetation and also the rewetting. In this area, as you can see in the right side, is it left or right? Left side, from your side, in the left side, you can see that this is the part where the government do the revegetation. And then in the right side, it is the area where the government leave it as natural succession or natural regeneration. You can see the difference here, and this is the picture of the 2023. And this revegetation is also is quite successful that happened in SILVANUS National Park, and it's also because of the, here if you can see there is a canal blocking as well in this part. So the most important thing is that making a canal blocking for now in SILVANUS National Park. And talking about the OFM as well, that can be used to be monitored, we can also see that we can use OFM to monitor this kind of program, revegetation, or even making the canal blocking. Let's say that in several areas or in certain areas, there is several canal blocking that is built by the government. So after that, for a couple of years, we can monitor it through OFM. So what we did as a SILVANUS team, the first one is we make an early survey in 2022, and we can see here that it looks beautiful, but actually it's a burned areas here. This is actually not a good area. You can see it from above. Here we take a picture of from the drone that you can see this is a post-fire. We also take a drone image of the benchmark forest that should be, this is a protected areas that never been burned before. And this is the rehabilitated forest. The forest that have been burned before, and then there is a rehabilitation activities in SILVANUS National Park. That's why we took it as pilot areas. And also we have consolidation with the government to run this project in SILVANUS project. And we, yes, there is a, this is the authority of disaster management in a regional area. And also we make an initial survey before the team of SILVANUS went to Indonesia. And then, yes, this is the picture when the SILVANUS team visited our SILVANUS National Park. We have a discussion with a regional agency, regional disaster management agency. Well, it's a little bit hard to pronounce. And we got a lot of information from the agency, how they rehabilitate the forest, how they make the first responder, and etc. And also, in Borneo Island at that time, we also have a discussion and we have a workshop, the same as the one that we did right now, in Palangkaraya with all of the Silvanus team members, and also with the authority, the community, first responders, and people that is related to the forest fire. And this area, as you can see, that actually this is a burned area. The thing is that the pit soil, normally we cannot see the burned area from above. We only can see that there is a fog that coming out from the soil. But the fire is normally an underground fire. So we cannot, it's quite hard to track the fire, and we can only see that, oh, there is a dead tree over there. It means that probably the fire will reach up to that area. And you can see here, this is the Silvanus team that is going to Indonesia at that time. And it's still burning, actually, in that part, but not in here. Okay. And also we're going to the inside of the forest, but actually this is it's a kind of a benchmark forest that is the condition is actually it's quite good. And also, yeah, the last is that we're going to our hometown, our university in Yogyakarta, and we conduct a seminar. It's a kind of a conference to disseminate our project. And this is the last picture that we took when our teams went to Indonesia. You can't see me here because I'm taking the picture. But I believe that actually Silvanus teams growing not only as a partners, but I believe that we are growing deeper as friends and also families, that hopefully our contribution to the through Silvanus will give so much benefit to the environment and also to the community as a whole. Okay, I guess that's all from our team. Thank you very much.
Thank you. Wow. Thank you, Kusri, for that detailed explanation of the data integration process. It's amazing to see how diverse data sources are combined into a single platform, making it even more powerful for managing wildfires effectively. And now we move to the user's perspective segment, and in this bit we have one special guest who will share his experiences using the Silvanus platform in real-world scenarios. We're thrilled to welcome Marek Gasparin from the Czech Fire Corps. He'll give us insights into how the platform is being utilized on the ground and provide feedback on its effectiveness in helping manage wildfire risks and responses. Marek, thank you so much for being here today. And you have the stage. Is it okay?
Yes, I think we are okay. I just want to say something very briefly. Marek and Marcin. You forgot to mention Marcin. He's our master. No, it wasn't there.
I apologize.
I know it's not. He's our the designer of the Silvanus front board. So Marek and Marcin want to do this presentation in a different way. So they want really to start and then be interrupted by you straight away. So all the questions that you had before, all the questions that you save, also for the other people they are sitting here, they will be there and they will be also interacting. So please make sure that we make out of this small session a proper sort of interactive workshop with you. For us, it's really important to get your feedback, to understand better what do you think about what you are doing. This is important for us. That's the reason we came here. And for you, it's probably also important to know what we have here, how you can use it, what you can get out of that, and what you can get out of the expertise of the people that are coming from Europe and from beyond, from Indonesia, and also beyond, because some of the developments here were also done in Australia, a partner of the project. So, and now it's Brazil. It's Brazil's turn, basically. So let's make it really lively and interactive. Thank you.
Hello. Welcome, everybody. My name is Marcin, and I'm from ITTI, the software company responsible for preparing the dashboard. So the front end, the visual side of all the effects of the work that my esteemed colleagues presented to you. And I would like to start with the idea behind the dashboard, because one part is the scientific research or the knowledge and powerhouses behind this, and the other part was the question how to present it in an easy and understandable way for different kind of users which will be using the dashboard. And not only the dashboard, because this is partially the effect of our work, also the many applications that you saw during the presentations, and the hardware and the methodologies that we developed to present all the hard work. So basically, we distinguish like two perspectives. We can say four, but I will be focusing my presentation on two, and then give it to Marek to explain it more deeply. So the authorities and the firefighters, which are actually the responders to the events, and the authorities who are regulating what the firefighters have to do and what they are able to do, their funding and such. So basically what you see is the main view. We call it the admin view. So all the other tools are there, but you have to think about them and the Silvanus in its current state as a proof of concept, right? It's not a ready-made tool. It's not something that you get from the shelf and buy and this is it. This is how it's supposed to work. This is presentation of capabilities, things that either apply to your situation in Brazil or in any other part of the world or not. And you have to ask yourself a question, what is your condition? What is your specific thing that you need? And we are presenting you the whole variety of solutions. So from the perspective of the user, you are interested in your problems, right? So a quick overview of those different panels. I will not delve too much into each of them since they were explained before, but you have them categorized in different roles. So we'll start with the role of administration. We call this authority. And of course, to keep you in touch, this is data from Europe, right? So currently we are in Gargano Park in Italy, but we'll be using, as my colleagues mentioned, also the data from Australia, from Slovakia, from all over Europe and the world. So as you can see, the panel already changed since authority is interested mainly in some measurable things that they can predict and upfront. So for example, fire danger index is a tool that can tell you where is the most likely fire to happen based on the color grid. The other tool that is available is health impact assessment. So the information from on-site about what is the condition of the air in the area and is it safe or not for people to be around, right? So it's in form of a pin, so it's an event generated by the hardware on-site. And you can see all the other different data that is taken from it. And the other part is threat alerts. Threat alerts is a general category which can geolocalize where exactly those alerts are happening, right? So you can get the idea from the different perspectives, since you can watch really, really closely from perspective of few kilometers up to the perspective of whole region or even whole country, depending on what body of authority you are representing and what kind of decisions you're actually making. So this may be very, very localized, or they might be global. The other part that is in interest of authorities, in case of fire happening, before the fire even happens is the evacuation route. So where is the actual road or the plan for people to evacuate from the place of accident? Also the drone flight routes. All of those different aspects that you see are the tools which authority can use to predict, to gather information, to make the most informed decision. And this is basically the phase A, right? So prevention of the event happening and to assure that we are best prepared. So those different layers are overlapping each other, giving more and more sources of information to the user, which can then make the best informed decision what should be next. And the other general perspective is the responder themselves, since the authorities have their time, right? Minutes, hours, days, weeks, however long they have to take to make policies, to make regulations, to allocate fundings, whatever the authorities have to do. They have those tools available to them. And since, of course, you have to imagine that each individual body of authority is different depending on culture, political state, the climate, you name it, right? So different challenges for different kind of people dictates what they actually need. And the other thing is the firefighter perspective. So the responders in general, they have to deal with fire immediately. So all those different kind of tools, they of course overlap, since firefighters can also make use of fire danger index to allocate their bases or respond more accurately to the situation in given season. And also there are more immediate informations, like for example, smoke and fire detections, which are on-site detection tools, which can provide you live information from the site and tell you if the fire is happening right now, not if it's possible to happen, not if it's there in 2 months, if it's there like in an hour, and you should respond to it. And this is similar information. Of course, this is live data, right? It's pre-prepared, but it's loading your experience at live as if you would during the event. So you can see the possible picture that was taken by the tool and information that it gathered, when it was, when it's located, and what's the probability of fire, since this image is also then algorithmically analyzed, right? So you can get the best information out of it, so your decision can be supported by the technology, so you will not make mistakes or false intrusions. Also, as mentioned before, you have tools like fire spread simulation, which can allow you to predict where the fire will be in the next hours. It has to load a bit, but as you can see, there is a lot of different, similar but different tools which are in form of events, since fire is an event, right? Ongoing event. Here you can see how the fire in this area can spread in time. And of course, this correlates, since you cannot really believe only the singular source of information. It's rarely fruitful. But if multiple different sources, not connected together, are giving you the same information, you should consider it happening. And it's also something that can reassure that our decision is actually grounded. Here you can see the fire detection at the edge tool, which analyzes live where actually the fire on the picture made by the tool is. So it's another layer of us, for us to reassure that we are making good decisions. And there is, as you can see, a lot of different tools excuse me, available. And I would like to give it to the Marek to explain what authorities and firefighters can actually do with all those informations and how it relates to your work.
Thank you, Marcin. Just only a short comment. Marcin is from ITTI, a company from Poland, which developed this dashboard application. it wasn't mentioned, and it's important to say. First, I want to thanks and acknowledge Rogerio and his team for big effort given to this event to hold, and for the hospitality given to us. Many thanks, Rogerio, and your team. So I know I'm a last contributor in the last session for today, so I will try to be as much effective as possible. I will try to explain our role, our end user perspective in the project Silvanus. I think it's very important, although the project itself is a research innovation project, that end users are part of the consortium of this kind of projects. For us, it's a great opportunity to learn new things, to try to test something, and I believe that same beneficial are we for our colleagues from universities and researchers and technology partners, because we are able to provide feedback for them, definitely. And moreover, what's important from my side, I think, is the fact that we are quite skilled to hold and organize all kinds of trainings and exercises. It's very beneficial for project itself. So I'm really glad that I have a chance to be part of this session, to promote the dashboard itself. Dashboard itself is just a showcase, I would say, of the project, but there is many things behind the scene. You can see. I'm not ITTI, I'm not developer, so I can see them too, but I was involved a little bit in the process of development, so I know that there is so much behind. But what's important to say is that what you can see, the dashboard itself or platform, Silvanus platform itself, is generic platform. It can be utilized not just only firefighters or civil protection authorities, but with all end users. It can be customized to your expectations. There you can see so many technologies which are involved, but it's not mandatory. So important is you can use the technologies which are beneficial for you, which are reliable for you, and that in general they needn't be developed in frame of a project itself. If you own or your own technologies, for example, you can integrate them outcomes to this platform. So so I'm not vendor to sell this. So, but I just only can express my feelings of this platform and dashboard itself. So, as I said, I really appreciate the fact that this platform is open and can be fully customized to your expectation to use. As I said, I'm a member of Fire Rescue Service in Czech Republic, and we act like firefighters and civil protection authorities. These two institutions have got a little bit different perspective. Firefighters are more or less focused on firefighting or and phase B, more or less. Activities of civil protection authorities are more strategic. So, but still, if you make some decision-making process, you need to have a data. You need to have a reliable data, and what's important, real-time data. It's a really challenge, and it's good because today, in these days, there are so many technologies which can be beneficial for all emergency response organization or end users. I'm really glad that this platform shows how they can be integrated and utilized. From, you know, as a civil protection authorities or firefighters, use very separate IT systems. One system provides you something, second one another thing, third one another thing, and so and so and so. There are so many platforms, so many systems. Its big advantage of this platform is everything is integrated into one place, And as I said, it's fully customized, and even under one institution, it can be utilized for different branches in different way. So that's our really big advantages of this this platform. Now I will try. Okay. Now I will try to make some sidestep of this platform and in some way react to some discussions done yesterday, day before yesterday, and talk a little bit about the opportunities given us by the project Silvanus and in general. We as emergency response institutions are, I must say, we are quite open-minded to solving the problems. You know, we need to accomplish the problem. It's up to you how you reach this problem. And it was very nice during this last year, for example, as we have a pilot demonstration in Czech Republic. It was given us like an opportunity to test new things, new approaches. For example, there were in presentation from Phase B, there were some pictures from Czech pilot. And for example, day before yesterday, we talked about the utilization of drones for firefighting, for example. You know, you can use them. We know there are cameras, thermal cameras. We know what to do with them. But for example, this demonstration in Czech Republic provided us opportunity to use air pollution devices to measure pollution in air by drones. You know, there are propellers and drones. They make some air turrets. Will be efficient this way or not? So we tried this. We used drones for making a mesh network in the scene of fire. As you know, I think you have got some experience like we, that it's really challenging to make a reliable connectivity in a hilly countryside. There are so many places you need to cover with some way to be connected with the colleagues to gather data and so on. We use drones for making these networks, for example. It was very good experience. We had the chance to even utilize UGVs for not just only firefighting, you know, but for example, for logistic task, to make hose lines, for example, to develop hose lines, to use remote control UGVs for evacuation of injured people from difficult terrains. So this everything provide us really opportunities to test something even outside of core ideas of Silvanus project, because there are so many chances and opportunities. I believe in close future even, because these technologies are rapidly evolving. I mean, especially regarding the UAVs and UGVs, autonomous functionalities. We had a chance during this project, for example, to see solutions of our colleagues from Australia, how big opportunities brings these autonomous vehicles for us, for the 3D mapping, for monitoring and so on. So that's my is the end of my talk. Thank you for the floor, and if you have any questions, so we are ready to respond. Thank you.
So you can see that it's constantly making photos which are pretty accurate and constant. So this is actually the Queensland area of the university, but this can be deployed pretty much anywhere. And it's very accurate. Thank you.
Thank you, guys. This was incredibly important to hear directly from the users and, about how the platform is performing in the field and where there might be still some opportunities for improvement. And now we have a few minutes of questions and answers. So this is the time where we can perhaps ask questions to how are we going to organize. Certo, mas aí tem vários apresentadores, tem que ligar 2 microfones. Yeah, maybe if the presenters could come to the front row, that would be very helpful. Yeah, maybe. Yeah. Okay, whatever works better. Could you hold on? Sure. I will just pass the mic. Sit. Calma. Kostas, just take. Marek. Come, Marek. Don't worry, I can. I'm only a delivery man.
Congratulations for your presentations, brilliant presentations. But thinking about incident management in the platform, in the front end, have you ever think about, for example, you can estimate the population you have to evacuate on that area or not?
In the context of our work, we are mostly based on data coming from the World Pop dataset. So this means that we have the data estimating the residents in the area.
Okay.
This is our best approximation within the context of the work we did in Silvanus.
Okay, as I saw, the number of population to be evacuated, how many vehicles to be used on the evacuation, but where do you get these people? The shelters are available on the display or on a layer or not? What is the capacity of this shelter? Who is responsible for this shelter? Do you have this information?
These are not one. There are many questions altogether. We have discussed them during our pilots. This is work performed by our colleagues that are not here today. However, we have been participating in these discussions. The main approach was that the authorities define the evacuation points, the reception points. They define some rules about the properties of the areas that are able to host people. For example, existence of hospitals. And of course, safe conditions, so they define this in the map. So the endpoint is defined and known by the authorities. And after you have your endpoint, your endpoints on one or more, then you can define the routes from your fire incidents to those evacuation reception points.
So is it possible to spot the shelter or a pin for the shelter and the building? The platform.
In the version that we have developed up to now, no. But it can be done. It
Okay.
can be easily done. We have focused up to now on algorithmic complexities and on the requirements we had collecting we had collected 2 years ago.
So, okay, just only, is it working or not? Yes. Closer,
Come close.
okay. Do you already process these data or not?
Yeah, we already have
okay,
this data.
There's no problem to make some layers into map to display them. So every kind of sources you have already processed is not problem to display in this map. As I said, it's open source. So each data you possess can be displayed in various levels, layers in the map. That's the point.
Okay, thank you.
I will add one thing, that this is still like a proof of concept, right? So the tools are there to show the route, which is the hard thing. To show the point and to validate it is actually the easiest one to deploy. So it is possible.
Moreover, one comment on this. Today we are talking mostly about the forest fires. But that was a point I have asked you. What are other challenges you face? Landslides, flash floods. All this platform can be used for these threats too. We are working on forest fires, but each sources you use, you can display. You can use in general this application for other threats, not only forest fires.
Anybody else? Rogério. Finally.
I will repeat a question that I've listening for many sources when I talk about Silvanus. Which are the steps needed to deploy Silvanus here in Brazil? How can we upload data? How can we upload maybe layers beyond layers related to the fire, not related to other fires? How are the steps to make Silvanus platform available to civil protection here in Rio, as example? Difficult.
I can try to give some answers or some guidelines or hints. You need to work with the Silvanus partners, actually, that deliver the tools. You can install it in any cloud platform, but you need to guarantee the interoperability of your data sources with the Silvanus Cloud platform then. We have a specific, in order to homogenize all these data and make them presentable to the dashboard that you have seen today, you need compatibility and interoperability. So your data sources need to deliver this kind of data in a compatible format so that it can be stored in the way that Silvanus, the Silvanus Cloud platform stores the data and visualizes then this data. So you need common data formats. And this is why you need to collaborate and develop this as a new project that for customizing the Silvanus platform for its different use case. So you need to invest on that as well.
If I may add, it is also a matter of which tool you are mostly interested. Because if you want to use all these tools, then we go back in our offices, we create a list with the data sets that we need, we put it in the, you give them to us, or you guide us where to draw this data, we put it in the platform, and it's pretty easy up to there. If you're interested in a specific tool, we will say we need from this list these two elements, let's say. So it's simpler. But all this is to experiment, okay? If you want to have a commercially operational tool, it's much more. We need to sit together and decide which tools, on which cloud, several steps in this direction.
A quick comment on that. Also, just to refer to the fact that the SILVANUS project got funding based on a contractual commitment that committed us to deliver a lot of documents. We call them deliverables. And these deliverables, most of them are public, and meaning that they are available to you. So a good starting point for this is to make probably to a selection of those deliverables, which are reports, documents, technical reports, where, for instance, the data structure is detailed, described. These are long documents. So that's a good starting point. And then, of course, the communication with the partners involved in the production of these deliverables, because the partners involved in the production of these deliverables are the partners, the same partners that produce or implemented the technology behind. So I think if there is interest, the starting point is probably the SILVANUS repository, where all these documents, at least the public documents, are available. And the Brazilian partners, well, they are partners of the project. This means I think they have access to all of them anyway, not only the public ones, but also the ones that are not so public. Sorry.
But yes, it is a co-funded project, which means that us as companies have invested our own money. So there are parts of deliverables that are public that you can, yes, everybody can find them on the net. In any case, as Nelly mentioned in FANIS, we can customize pretty much any kind of solution we want. This is a proof of concept, and you can use it as it is. Of course, it's going to be available for a couple of months per our commitment, but for future steps, we would be more than happy to take more requirements and customize solution. That's pretty much why it's a co-funded project and not a 100% funded project from the Commission.
More question from me. I've heard so many questions, so I'm here to repeat. It's important to be hashtag. Is it possible to a trial period for Brazilian partners who was here at the morning and is here in this afternoon?
I think that they can definitely experiment with the existing data sets. As soon as Martin gives you a user ID, or which is pretty easy, very, very easy, just an email.
Yes, just to test what you already see, it's available worldwide, right? I did not use VPN. It's here, right? I can give you a link and passwords, of course, by the discretion of
it's
the
one
project,
link
right?
and passwords.
Yeah.
So it's okay.
For the stakeholders also.
Yes.
Yes, but only
Yes.
to experiment, right? If you want your own data put, or you have your sensors that you would like to give input into SILVANUS, then it's what Nelly said. We have to sit down, discuss the process, and then put your data.
Okay. If a stakeholder is interested in some user products, how can it reach the developer?
Okay,
How can
that's easy.
the product can be used
That's
here?
very easy. He sends an email to me and I provide all the emails. The deliverable will be public. It will be in 1 month from now, but it's very easy. You send an email to me and I send you the
yes,
names,
with respect
the
to
contacts.
the user products, as I said also in the presentation, they are a bit more sort of unified, because they have been developed by a subset of the consortium. This means there is a bit more of a planning towards commercialization, so they may be a bit more advanced. And as Nelly said, it's a matter of just contacting the the owner of the user product, and it will be much easier. That's much easier because here we are talking about the overall framework, and this overall framework is developed by 50 partners, so it's a more challenging thing.
Sorry. Okay. The camera detect smoke or fire a long distance, example, 1,000 meters, or only near the smoke or fire.
I don't know the limit. Kostas, it is.
By large distance.
Yeah, distance.
Yeah, I don't know the range, but we can check with the developers. Normally, it's a line of sight, so it has to be hundreds of meters. Yes.
Okay, thank you.
You are talking about the fixed point cameras or the drones?
No, cameras.
The fixed
yeah,
point
fixed.
developed by.
Because the night, nobody.
In the SILVANUS projects, we have experimented with specific devices providing compatible data as well as we mentioned, with these types of systems provided by our partner. However, there are a lot of other systems that could be adapted to SILVANUS that have higher granularity, longer distances, technology advances in this case. So our device had a specific set of specifications. But these, of course, can be improved as the time passes. So, yes,
yeah, because
right now we are in the range of hundreds of meters.
I live near the forest, and more or less 1,000 meters.
Yes. And the device specifications need to be a subject on its own. You need to define the characteristics of the camera, the hardware capabilities of the device. It's a complex design.
It's detect the first
and the point where it is placed as well.
The beginning.
Yeah.
Okay. Yes. Thank you.
Don't take me wrong. All the information exists in the deliverables. Why I'm saying send an email to me, send an email to Kostas is to accelerate the process. So for the cameras and the fire detection through cameras, it is Jose from Atos. For the cameras. Yes, for the analysis of the cameras.
Do you want one mic just for you?
From your experience, do you believe the future, is it possible to have any call from European Union to make this kind of consortium again with institutions from Latin America and other parts of the planet?
Maybe I can say something on that. Yes. Well, the quick answer is yes. The quick answer is yes. The less quick answer is sometimes it's tricky. But the Commission has instruments in which the call addresses exactly that. So a cooperation between not only Brazil, but Africa, Europe, Asia, Europe, South America, and Europe. Now, in the context of the Green Deal, which is where we are now, at the time of the call, there was a great emphasis on getting the players, key players, because the problem is global, and when a problem is addressed in the context of a call, then they want also to involve the key players. And the key players are not the same countries depending on the topic. So the key player on AI may not be Argentina or I don't know, Venezuela, maybe another country, right? Brazil, Indonesia were seen as key players for this type of project. Now, and this means that there is a good opportunity there. Probably a bit of bad news is the fact that the funding has been reduced for circumstances that you may know very well, in the Green Deal, the funding has been reduced, and it's not as big as it was planned at the beginning. This means it's a bit more challenging, but in general, it's possible. Yes.
Okay, Rogério, there are a couple of things. There are a couple of frameworks that Brazilians and Europeans can collaborate. You come from a university, Marie Curie is available for you. That is one instrument to push different kind of collaboration. Now, when it comes to Horizon, these kind of projects that are common research projects, yes, we had the opportunity under Green Deal, which has been now integrated in different cluster, because Green Deal remains as a key policy for Commission, but has been integrated in other calls. So they have transferred the budget and integrated it in different other calls. At this case, we have two options. One option is what Ebrul said, dedicated call for Brazilian partners that are getting funding from the Commission side. And then you have another option that you get, we call them like usually the Commission asks us to embrace collaboration with non-EU partners, which means that you can bring your own funding from your national funding. After getting the approval of the proposal being granted, we have other non-European members that do that. And this is another type of collaboration under the same framework, but the funding comes from your national part. But I think that most of us in Silvanus will be looking for further collaboration with our non-European partners. With Kusrini, we've tried before, and I'm sure we'll reach out to you again. But there are many types of instruments that you can start looking into.
I can add something to the last point that Despina just mentioned, the fact that there is the possibility of cooperation when you get funding from your own agencies. Keep in mind that it's easier for you to get funding from your own agencies if you are in a proposal that has been accepted in the context of cooperation with the EU. So that is an added point that helps to have more access to this type of sources of funding. No, it's that's open to anyone. So you can see here.
Yeah, okay. Public authorities, companies, universities. It has to do with a use case that you could bring. You saw how Silvanus works. Like, it would be great if we could collaborate with you and see how people work or build on top of Silvanus or do different things for maybe other areas that you find that they're interested regarding security or, other, not going even beyond the environmental aspects, right? So obviously there are many people that can collaborate under this framework.
Just to add that there is also a bit of if you look at in which direction the politics are going, that helps also a lot. For instance, if you see that the EU is right now trying to strengthen the connection with South American countries, this is a good sign that this is the moment to apply, because they want to show that. And especially if you can demonstrate that you have support from your own agencies, or let's say that it adds value to your users, or to your country in whatever level, these type of letters and commitments from your country help a lot. Because in the end, it's a competitive process. So we are in Silvanus after the submission of a proposal addressing a call, and in this call, there were many submissions. So all these submissions were evaluated by experts, also worldwide experts in the field, and the best proposal is taken out. So they get ranked, they get marked first, then according to this mark, ranked, and then the funding starts from the top one down till the money is gone. So all these things help. If you have this and this ingredient, and you have this other, and you have this letter, and you have Lula da Silva supporting you, all this is important.
This means that you would be interested, you find it useful? I'm turning back a question. You are asking if we think that there will be other calls. Should I assume that you have seen Silvanus as a fruitful collaboration, that you gained something from this, it was interesting for you and you would like to extend?
Yes, yes, it was a good experience to be with you. I learned a lot. I will talk about it tomorrow, and no, and there is some interesting lessons I've learned that we could improve our own proposals here in Brazil. So it was a good experience for us. Okay.
Can I say something here? A bit more because we are too positive now, a bit more on the controversial side. Because I have been talking also with the Silvanus partners, and thank you for the organization of this event. Very, very nice, very good, well done. But what we missed was probably a bit more of your participation a bit earlier, right? I'm not blaming you. I say I am going to be a bit controversial now here. I'm not blaming you or anyone, but I think if we would have you, or if we would have this meeting, let's say 2 years ago, we would have a lot of good time to do much, much better things, because now the problem is we are finishing the project, right? And yes, we can, hopefully we can get a follow-up, right? But this is not guaranteed, right? So it's good. So it's good to take this as a experience, lesson learned, and yet try to get together better for the next push.
So thank you very much. This was an incredible afternoon with you all. As we come to the end of this showcase, I would like to thank all the presenters for their time and excellent presentations. It's been a truly informative session, and we've learned a lot about the technology, the developments, its practical applications. Thank you also to all of you for your participation and your questions, and we hope you now have a clear understanding of how the SILVANUS platform is helping to address the critical challenges in wildfire management. And I believe we have some coffee for our guests, so it's time for a bit more coffee and food. Hopefully you're hungry. So thank you. And see you tomorrow.